Your final lesson of 8th grade math, 8M6, lesson 14, association between categorical variables. Now, this is not a traditional class that used to be taught in math, this statistics stuff, but this is extremely, extremely powerful stuff that you're going to learn today. And we hinted at it yesterday in lesson 13, showed you a few of the keys as to how to do it. But stick with me today, and I think you're going to find it fun, and I think you're going to understand the power of knowing how to do this type of math. So let's get on with it. We're going to look at some examples, one of which we did yesterday, and look at 2 other examples. These, the work that we're doing today is going to be exactly the kind of stuff that you're doing in your homework. And so knowing how to do what I teach you will directly benefit you on tonight's homework. Okay, so what I want you to recall, this is what I want you to recall from lesson 13. Recall from lesson 13. Bivariate data. That's when you have two variables whose relationship can be shown in a graph or table. So like today we're going to look at data. We're going to look at the height of boys and then what grade they're in. So 6th grade boys and 8th grade boys. So, and then how tall you are, what group you fall into. So you could be a 6th grade boy who's under 9 feet, under 4 feet 9 inches. You could be a 6th grade boy between 4'9" and 5'2", or what I'm going to call a taller boy, which is over 5 feet 2. Same, you could be 8th grade and have any one of these characteristics. So we have 2 variables. This is called your height, and this is called your grade. And the question is what are they associated? Okay, and we're going to use these tools that we learned how to calculate in lesson 13 of calculating column relative frequencies, row relative frequencies, and to find out whether or not these 2 things are correlated or associated. In other words, if you know one of the variables, does it change the likelihood of having another one of the variables have a certain value? In other words, our 8th graders tend to be taller than 6th graders? Well, we think the answer is yes, but we're going to look at this data that we collected at our school and verify that that is true. So let's go ahead and fill in this chart based on this data that we have. So in 6th grade, so we're going to look at our 6th grade class and look at the heights of boys and put them into 3 buckets. And we're going to look at 8th graders and put them in the same 3 buckets. And then we're going to do some math and prove that they are indeed associated, or maybe they're not associated, but we think they probably are. Okay. So we have 18 boys in 6th grade who are under 4 feet 9. So that goes here. We have 45 boys that are between 4 feet 9 inches and 5 foot 2 inches. So that's 45. And then there's 7 that are over 5 feet 2 inches. Now in 8th grade, there's only 3 that are shorter, 42 that are on the tall side, and then 15 in between. So we get a sense here that it's probably going to be true. But let's do the math and let's really work it out. And I'll show you how to prove it. So what have we not done? What did we do in lesson 13? Well, we figured out these column totals and these row totals. So let's go ahead and do that. So this is 21. This is 60 if you add 45 and 15. And then here we have 49. Similarly, on 6th grade, we have, if we add those across, we get 70. And if we add these across, we get 60. So if we add these down, we get 130. So let's verify that we got the right number here. And how do we verify that number? Well, we add this way, and then we have to add this way. And if we add this way and get this number, then we've added correctly. So let's do our smart math. What's 21 and 49? We should be able to do that in our heads. That's the same as 20 plus 50, which is 70. And 70 plus 60 is 130. So we have a correct chart here. So we haven't gone ahead and calculated these guys. We have calculated our totals. So let's move those totals over to the next page. And we're going to do a little bit of math. Well, I think I can just paste this and put it right over the top. Oh, wow, look at that. Fits right over the top. Okay, good. So now we've calculated our totals, which is step one of calculating or figuring out whether or not we have a association between our data. In other words, is the stuff that's on in our over here, there is our grade and our height. Are they associated? Our taller kids and higher grades. So we're gonna do let's calculate all of our frequencies. So our cell relative frequency, if you recall, is basically each cell divided by the total. So let's go ahead and do that. And let's do 18, and we're going to round to the nearest percent. So this is 14%. Let's do this we'll do this in red. So this is 14%. 45 divided by 130 this is 35%. And 7 divided by 130 is 5%. 3 divided by 130 is 2%. 15 divided by 130 is 12%. And then 42 divided by 130 is 3%. So we can add our totals, and we can 16%, 47%, and 8%. Adding across, we have 40, 54%. And adding across here, 15, 16, 17, we have 17. Well, what did we do wrong here? 8. Oh, no, this number is wrong. This number is wrong. 42 divided by 130 is equal to 32%. This is 32%. So this should be 37%. And so here we got 20, that's 14, and this is 46%. All right, that makes a lot more sense. That's 46%. And so if we add all the way down, we get 100%. Good. So what does this tell us? How many boys, of all the boys in 6th and 8th grade, what percent are under 4'9" and in 8th grade? Well, that would be 2%. If I ask you the question, what boys are over 5'2" tall and in 6th grade, you'd tell me 5%. That's the percentage. Okay, so that's our cell relative data. Now we're going to calculate our row relative data. And this row relative and column relative data is extremely important for answering the questions of association. So watch carefully, row relative and column relative values. So in a row relative value, to get each number, to each percentage, we are going to take our number and we're going to divide it only by our row total. Our row relative values is our number divided by our row total. So we're going to take 18 divided by 70, and we get 26%. And then we'll take 45 divided by 70, and we get 64%. And then we take 7 divided by 70, and we get 10%. And that adds across to 100%. So 100% of boys in 6th grade have some height. So the question is, this just tells you row relative only tells you about the row 6th grade. So in 6th grade, 26% of our boys are shorter, 64% are medium, and 10% are in this tall category. Let's do the same thing for 8th grade. So here we're going to do 3. We're going to do each number, and we're going to divide it by this row total. So we say 3 divided by 60, and that's 5%. And then we take 15 divided by 60, and that's 25%. And then we take 42 divided by 60, and that's 70%. And that adds to 100%. And then we get 31%. Here we get what did we do wrong? Oh, these don't add. Oh, right, these don't add down. You don't add these down. All right, that won't work because we're only talking about row relative totals. So these percentages are percentages of this guy over here. So adding percentages down, it doesn't work. Okay, so column relative, we're going to do our each cell, and we divide it by the column total. So let's do that. 18 divided by 21 is 86%. And 3 divided by 21 is 14%. And so for that column, 100%. So of our boys under 4'9", 86% are in 6th grade, 14% are in 8th grade. 45 divided by 60 is 75%. And 15 divided by 60 is 25%. So of our boys who are between 4'9" and 5'2", 75% are in 6th grade, 25% are in 8th grade. Now over 5'2", it's going to be a little bit different. 7 divided by 49 is 14%. And 86% of our boys over 5'2" are in 8th grade. And these totals, we don't add we only add down in the column relative. So the way that we know that there is a correlation, now we've done the work, but I haven't told you the answer. So the work is right here in this row relative and column relative data. And you could choose either one. Either one. You don't have to do both. I have done both to show you how to do both, but you don't have to do both. So I'm going to cut over here to green here, and I'm going to show you. Now what you need to do is you can look on your rows and compare them in your row relative data. And you can look on your columns and compare your columns if you're in a column relative situation. Now, the thing is if these numbers are significantly different on any one of the pairs, then you have an association. Let me write that down. If any row data is different, is very different, then you have an association. Between the variables. Okay. And similarly, for column relative, if you did a column relative data or a column relative frequency calculation, if any column, you know what I'll do? I'm just going to do it like this because whoops. Let's undo that real quick. Let's go over here and let's erase that. Now I'm going to come back over here. I'm going to copy that. I'm going to put this right here. And I'm going to then take this out. Oh, well, I'm trying to say, I think you know what I'm trying to say here. What I'm trying to say is if any column, so instead of if any row data, the answer is if any column data. If any column data is very different, then you have an association between the variables. Okay, now let me show you this. So between the rows, here we have 26. Whoa. Here we have 26, 64, and 10. And that's very different than 5, 25, and 70. In fact, all three of them are very different, right? So 26 is very different than 5. 64 is very different than 25, and 10 is very different than 60. So therefore, we have an association. And similarly over here, we have, you look this way, you look between any pair of data, and if they're different, if any of them are different, then you have an association. And here I have 86, 14, and here I have 75, 25, which isn't that different, but then 14 and 86 is very different. 75 to 14 and 25 to 86 are very different numbers. So we also have an association. If you ever do row relative data and column relative data, they will both either show an association or both either show a not an association. So you'll never get one answer from doing one and one answer from doing another. Okay? So that's the way we do the calculation. We're going to do it 2 more times with 2 different examples to really show this. Now, before I switch to the next page, I want to do 2 things. One, I want to give a happy cat for doing all of these calculations. And the second thing I want to do is I want to state what this means. What does it mean that there's an association? It means that there's, between the grade and the height, they're connected. They're connected. Association means a connection or a correlation. In other words, if you're in a different grade, you're more likely to have a different type of height. So in 6th grade, you tend to be shorter, and in 8th grade, you tend to be taller. There is a connection between height and grade. Okay? Now we're going to go and we're going to look at another example. So here is an example from lesson 13. Remember lesson 13, we did an example where we had boys and girls, what did they like to use on their homework? So we can use, I want you to, so I'm going to call this homework help, and I want you to do all of the calculations. You're going to need to do your totals, and then you're going to need to make a choice to do either a row or a column frequency, a column relative frequency or a row frequency. Okay. I assume you're back, and so now let's do our calculation. So we're going to got to calculate all of our totals. I'm going to do it as a row or column. All you needed to do was do one or the other and make a determination about whether or not they were, whether they're associated. In other words, if you're a boy, are you more likely to use one device, and a girl, are you more likely to do something different? So let's figure that out. Here we got 25, 17, 13, and 20. So this is 30, 50, 75. Here we have 13 and 9, 22 and 29. This is 45. And here we have 10 and 20 is 30. So it adds down to 75. So check. Let's give ourselves a happy cat if we got this graph, this chart correct. Okay, now let's do our column, our row relative totals. So to keep each thing in this, to calculate each cell in this table, we have to take each number and divide it by our total. So we're going to take 13 and divide it by 45, and we get 29%. 9 divided by 45 is 20%. 7 divided by 45 is 16%. 16 divided by 45 is 36%. And this is rounded, so if you add this across, you get actually 101%. But it's because the error is rounding. Because we rounded these percentages. Okay, on this next one, 12 divided by 30 is 40%. 8 divided by 30 is 27%. 6 divided by 30, I'm guessing, is 20%. And then 4 divided by 30 is 13%. And so here we get 101%. Okay, so that's our row numbers. And before I give you the answer, I'm going to do our column relative numbers. So here we got 13 divided by 25. 13 divided by 25 is 52%. And here we have 48%. 9 divided by 17 is 53%. And here we have 47%. 7 divided by 13 is 54%. And here we have 46%. And then we have 16 divided by 20 is 80%. And here we have 20%. Okay, this is going to be a good example for identifying whether or not we have an association. So let's look at our row and see if it's significantly different. If any of the numbers are significantly different, then we have an association. In other words, being in one column makes a difference. If you're a boy, you're more likely to have one pattern, and girl, more likely to do another. Well, 29 and 40, I think that's probably enough to say we have an association. These are different. These are different. 20 and 25, again, these are pretty different. 16 and 20, that's going to be close. But 36 and 16 are very different. So because we have any different ones, all we needed is one that was significantly different. But since we have 3 that are really different, we know that there is an association here. We have an association. Check. So if you got that right, did these numbers correctly, happy cat yourself. Now notice, it didn't have to be. Some of them could be close, but because one of them is very different, when we looked at our columns. So again, we're comparing columns. We compare. Okay, so now what we're going to do is we're going to look at our column data, and we're going to compare and see if our pairs are different. Well, between here and here, these are pretty close. So between 1 and 2, these are close. These numbers, 52 and 53, 48, those are close. And hey, here we go again. Between 53 and 54 and 47, these are close also. But these are, when we look at the between column 3 and column 4, wow, these are way different. 54, these are very different. So because we have one pair, and these are very different from here to here, and these are very different. So between 1 and 4, 2 and 4, and 3 and 4, these are very different. So because just one column is very different, we have an association. So if you got that right, happy cat yourself as well. So we got happy cats and we got spinning happy cats. And we'll make this guy smaller. So very good. So what is our statement here? What is our statement about there is an association between boys and girls and preferred internet browsing technology at my school? In other words, if you're a girl, you're more likely to have a different pattern of usage than if you're a boy. If you're a girl, you're more likely to use a computer. If you're a boy, you're more likely to use a phone to do your browsing. That's one way to say it. Another way to say it is, phone usage is very prevalent among boys for their primary internet browsing, right? So while for the rest of the devices, it's more even. If you're looking at students that use tablets, students that use laptops, or students that use computers, it's about 50-50 on whether or not you choose a boy or a girl. But for phones, it's very different. Okay, so there is an association between the gender and your preferred browsing technology. Now let's look at one final example, and I'm going to let you do this one all on your own. So there's some ordering information for a school at an auction dinner. Okay, so here it is. This is homework help still. So men, there was there are 103 beef orders from men. This is the way to read this. There were 70 beef orders from women. There were 42 chicken orders from men and 29 chicken orders from women. So you can figure out that there was 145 men. Of the 145 men, 103 ordered beef and 42 ordered chicken. For women, there was 99 women and 29 of them ordered chicken and 70 of them ordered beef. So what I want to ask you, is there an association or a correlation between gender and entree preference? Okay, so the gender, male or female, and then the entree, chicken or beef. So I want you to go ahead and make a determination. The big question, this is your final test. Is there a association between the two? So I'm going to pause. So I want you to pause and try, and you can do your row relative frequency, your column relative frequency, and your total chart to make a determination. Okay, now I assume you're back, and I assume you've tried this. Now you know that you need to have a totals table. So we're going to make this our totals, and we're going to fill in all of our numbers. Okay, men that ordered chicken, that was 42. Men that ordered beef, 103. Women that ordered chicken, 29. And women that ordered beef was 70. So here we have 173, and here we have 71. If we add across, we have 145, and adding across here is 99. If we add down, we get 244, And our check, 71 and 173, is also 244. So we got the right number. Good. Now we're going to do a row relative frequency. Male and female, chicken, beef. So we do that, our row relative frequency, we're going to, our row frequency, we take our 42 and divide it by 145. 42 divided by 145, and we get 29%. And we take our beef total, 103 divided by 145, and that should be the 71%. And for the females, we get 29 divided by 99, and that's basically 29%. And this is 71%, 100%. Now let's do our column frequency. Men, male, female. Chicken, beef. And then we do 42, we're going to divide this way. So 42 divided by 71 is 59%. And then 29 divided by 71 is 41%. And that adds to 100. Beef, we do 103 divided by 173, and we get 60%. And we divide 70 by 173, and we get 40%. So now what we're going to do is we're going to compare our columns, our rows. We're going to compare our rows and look and see if they're different. And the answer is no, they're the same. And let's look over here at our columns. 59 and 41 and 60 and 40. These are very close, very close. So we're going to say, so there is no association. So what does it mean for there to be, and we're going to give happy cats for the 3. And so what does it mean for there to be no association? So no association means that there is no connection between gender and entree order. In other words, if you're a man, you're about 29% likely to order chicken and 71% to order beef. If you're a female, you're 29% likely to order chicken and 71% likely to order beef. If you want to look at it as a column of people who ordered the males, 59% of the males ordered chicken and 59% of them ordered beef. Of the people who ordered chicken, 59%, okay, sorry, of the people who ordered chicken, 59% were male. Of the people that ordered beef, 60% were male. Of the people who ordered chicken, 41% were female. And of the people who ordered beef, 40% were female. So there's no association between your likelihood to order one entree and your gender, or between your gender and likelihood to order one entree. So that's it. That was 3 examples, and hopefully this makes a lot more sense to you how you can do this type of math. Now you can use this on any type of experiment you want. You could actually run this experiment in your school and find out if there is a likelihood or an association between favorite color and gender. You could do this in your class maybe. You could say, hey, I want to run this experiment in class, and we'll see who likes red, blue, or green as your favorite color. and you can ask the boys and the girls. You could also see if there's an association between maybe the people who sit in the front of the class and the people who sit, if you sit in front or back, and how many hours per night you study. Do people who sit in the front like to study more? That might be an interesting question. So then you'd say, do you study more or less than, say, 20 or 30 minutes for this class per night? And that would be one question. You study more than 30 or less than 30 minutes per night. And then on the other axis, or on the other side of the chart, you could say, do you sit in the front? You could take the front 2 rows and then maybe the back 2 or 3 rows and make those be groups. And so you could ask different kinds of questions. You're going to say, do people with brown hair like different types of ice cream? Do they like vanilla more or chocolate more? Or people with, blonde hair, do they like vanilla or chocolate? So there's lots of questions you can answer. So I love teaching you math this year. This is the last lesson of the year. This is it for 8th grade. You're ready now to move on to high school level math. It was fun teaching you. Take care, and we will be talking to you soon. Maybe we'll do another year of math. I don't know. You tell me if you need me to do more. I am listening. And I give you credit for making it through 8th grade math. Over and out.